Right guys, so today we're going to be doing an LS400 95 to 96 model 1UZ non-VVTi for use with a manual gearbox. So let's get into it. Right, as I said, this is going to be an LS400 95 to 96 model. It's not the 96 to 97 because that would have an immobilizer in it for the European models and the American models. This is going to be for use with a manual gearbox, but we'll go into more detail about that when we go through the layout. Okay, so as you can see from here, it is a completely brand new harness, obviously with the 1UZ non-VVTIs because they're so old. And obviously we've come across many issues with the old wiring harnesses and bad connections and all sorts of drama. So now we just remake them all brand new so that obviously we don't run into any of those issues, okay? So first thing we're going to do is, because it's brand new, we're going to go through the build process so you can see exactly what it entails when making one of these harnesses. Right guys, so there you see all brand new wire, all nicely twisted, all heat shrinked up, and all the sub harnesses you can see there that are built for this particular engine harness. We'll go through that as part of the layout, see how they connect and everything. But if you watched our videos before, again, same format. We're going to go through the layout first, and then we're going to go into the testing, one with the ignition on and another testing section with the engine actually running. So let's jump into the layout and let's start right here at the ECU itself. Okay, so as you can see over there, we've got 4 plugs on the ECU, all unique, so you can't plug them into the wrong place. Nothing to worry about there. Then we head over to here, and this is where everything starts breaking out. So the first section is coming from the harness underneath there, and it pops its way to the fuse box over there. The other section that mainly comes from the ECU pops out and makes its way over to here into the fuse box over there. Now, what you may have noticed in this particular case, there's not a connector in there. That's completely normal because this is being used for a manual, and the way we do our harnesses now is we actually make the harnesses work for both an auto gearbox and a manual gearbox, which we'll go through as we go through the layout. You'll see exactly what I mean. But that's why. So in this case, that plug would be for an automatic gearbox, and in this case, not running one, so that plug is empty. But the fuse box itself is capable of running both an auto and a manual as well. Okay. We then have the client plug over there, which is all the wires that the customer is going to connect inside the vehicle, which we'll go through at the end of the layout, because I'm going to go through here, which every customer gets with their harness. Okay. Now, saying that I do make the harnesses work for both manual and auto, what I have done in this case is I have added a connector called manual, and this is capable of having a reverse light and 2 wires for a speed sensor. Now, most speed sensors are Hall effect style sensors. They do have 3 wires, but that's absolutely fine because every Toyota uses a 12 volt. So there is already a 12 volt going to the gearbox plugs at the back, which you'll see in a minute when we go through the layout. So all I basically do is bring a wire here for a reverse light. So basically supply 12 volts when you're in reverse. and then the sensor ground and the signal. Now, if you take Toyota, and the way that they do it is they take the ground for the speed sensor at the back of the gearbox to the actual cluster, and that's to avoid ground loops. So we've replicated exactly what they've done there, okay? Right, so moving along from there, we then get to our grommet, okay? There's a piece of SCL heat shrink on there, so that is so that when you guys get the grommet in the correct position, you can then just heat that down. SCL is an epoxy lined heat shrink, so if you have a look here, there's a bit of epoxy oozed out there when that's shrunk down, so that will seal it up nicely when you do heat it down. Once we get there, we get to this breakout section over here, and that is going to go to your two igniters, so igniter right and igniter left. Now, don't get confused. There's no such thing as a left igniter and a right igniter. This is for the engine harness that's important, okay? So you can swap these plugs out, you can swap them around, nothing's gonna change. But the major thing with this is that you do need to earth these very well. Now, we do give you quite a lot of wire over there, so bear in mind they're coming out hopefully pretty much close to where the grommet is. So you can mount these igniters on the firewall, in the chassis over here, or wherever you want, but just make sure that wherever you mount them and the bolts that you use to mount them through here, okay, that they have a good earthing surface to go to, okay? If you're unsure, you can maybe take an earth wire from the bolts there and then just take it to the battery or to a good point on the chassis. Either way will work, all right? Right, so moving along from there, we then get over to our molded T-piece boot over here. So the engine harness is gonna carry on that way and then go this way. We're going to do this way first, and then we'll come back and go to there, okay? So from here, it just goes down, and I just tuck it underneath there till you get to about there. If you can see, if I can get it to focus, you can see down there where my finger's pointing, it breaks out and goes to the TPS sensor, okay? So that plugs in over there. Again, everything's labeled for you guys. And the harness carries on over there and breaks out towards the front here. Now here it goes sort of underneath all this covering, so I'm going to try and show you as best I can. But one thing that breaks off is going to be your coolant temperature sensor. So you can see it says CLT over there. That gray plug, that's your coolant temperature sensor for the ECU. If you take a look down in here, you can see the two white wires there, but there is your coil plug over there. And if we take a look underneath here, you'll see there is the cam sensor over there. Okay. Then we have our temperature. Now this is a wire that we put in so that you can run your own temperature sensor for a gauge or your gauge cluster. Okay, so for example, if you had an older vehicle that had a dedicated coolant temperature sensor in the engine that was only used for the gauge, well, you can put that in place of this one because it's a standard 1UZ non-VBTI gauge temp sensor. Okay, you could swap that out for your one and then just connect this wire to there, and then that wire just comes out as one of those wires over there, which we'll explain when we go through all of that. Okay. Right, then moving along, the harness will come down here, break out over here, and then that goes off to our MAF plug, or mass airflow sensor. There you go. So that plugs in there. The mass airflow sensor for the 95 to 97 models use this one over here. Okay, so that's part number 22250500060, which I think actually a 1JZ LS400 uses the same mass airflow sensor. But again, you can check on Toyota DIY. If you put your ECU part number into there, go into the air filter or air cleaner section, and you'll see the mass airflow meter there, and you can see what part number is relevant for your ECU. Okay. Right, moving on from there, we go down to here, and then it breaks out here and goes to the alternator. Now, again, we do put the alternator on a sub-harness for a multitude of reasons. Number one, you can get an alternator from a very early 1UZ non-VBTI that had the big round plug. So again, we can get you the correct one for that. You can also use a 3UZ 6-speed one that came with that 4-pin sort of square plug. They all fit on because the UZ blocks are the same, so they all bolt on. And obviously then you would need to swap this out for the 4-wire one. So if you ever have alternator problems and you can only find a 3UZ 6-speed one, not a problem with this. You just phone us up. We'll make you a sub-harness section to go to that 4-wire one. Just be very careful with the 4-wire one. The only one you can't use is the one from the Crown Majesta, because that actually had all 4 wires going to the ECU to be controlled. Now, in a lot of the cases, like the GS430 05 to 08/09, they had a 4-wire alternator, but they only used 3 of the 4 wires. Same applies to the LS430 as well with the 6-speed model. If you take a look at any of my LS430 2003 to 2006 ones, I do explain it a bit better there as well, so you can have a look at that. Okay, and then lastly, coming down there, it goes down underneath there. Let's see if I can pull it out here, and that is for our O2 sensor. Okay, right. So that's that. Let's pop back over here, and I'm actually going to hop over to the other side now, and let's carry on with the harness coming out of that section over there. Rightio. Okay, let's grab a seat here. Right, so there is your T-piece over there. We have our earth So you can see here, it goes to an earthing loop. That will be labeled GND for ground. Then over here we have injector, so that's a 12-pin DTM connector there. And then over here we have ISC or idle speed control, and that's a 6-pin connector over there. So they come off and go to these sections, but you'll see disappear underneath here. So what I'm going to do now is cut to a photo so you can see how that looks. So this one's from the top, so you can see where everything goes. And then you'll see that I have a section that pops out that goes to injectors for the left bank. That'll be injector 1, 3, 5, and 7. And then it pops off and goes to the injectors for the right bank. That'll be injector 2, 4, 6, and 8. And then lastly, at the very end there, you'll see it pops off and it goes to the idle speed control, which is all stepper motor at the front there. Right, okay, so that's that section over there. So also coming off of here, we then have our sub-harness connectors. So this is one that goes underneath here, and it goes to the starter motor and the knock sensors. So again, I'm just going to cut to a photo of that now. So you see this is an overall picture of it. Then you'll see that it goes to the starter solenoid, and then it goes to knock sensor 1, and it goes to knock sensor 2. Okay, now while I'm back here, when you're talking about this engine, where you're talking bank 1, bank 2, or left bank or right bank, you're always looking from the driver's perspective. So this is left bank, so this has injector 1, 3, 5, and 7. This is right bank, so it's going to have injector 2, 4, 6, and 8. Okay, now that means when I have injectors, when I have the knock sensors labeled as knock 1 and knock 2, this is bank 1, so knock 1 is on this side. And this is bank 2, so knock 2 is on this side over here, okay? Starter solenoid, that's straightforward. You can see it only goes to one place, okay? But they are all labeled underneath there, as you can see, so you know exactly what you're putting in there. Right, you can see the harness carries along there, and that's the main section over there. It pops out over here. Now, this is where we get to our gearbox plugs, okay? So in this case, you'll see I've made them two different types of DTM connectors. So again, you cannot get them wrong. Now in this case, because he's not using anything, we just have them sealed up with seals there. We've got a wire in here to bridge the neutral start switch, and that obviously plugs in over there. If the customer had opted to have all the wiring for a reverse switch and everything, it would be incorporated into these two plugs over here, okay? Well, I think it's only one plug it would go into. But anyway, it would be in this one over here. So it would come out here and it would come down to go to a reverse light or and a speed sensor if required, or just a reverse light. It doesn't really matter. You can have either or. Right, moving along there, the harness goes down through there. So obviously I'm not talking about the injectors because I've already showed you those, and they remain a completely different section harness over there. And again, the reason I do that is if you want to take the whole intake off, you can then just unplug these two over here, and you can pull the whole intake off with the injectors and the idle speed control, which is this one over here, without having to disconnect all of that. And the main reason of that is because basically these standard connectors that come on your engine harness have very limited connect and disconnect cycles, whereas these DTM connectors have loads of connect and disconnect cycles. So effectively, it's much better to unplug that and pull your intake off than to actually disconnect all of these every single time you want to take it apart. But anyway, I digress. So harness runs along here, and we just tuck it away underneath there, as you can see. And then it pops out at the front over here. And then it goes to the cam sensor for the left bank over here. Pops down over there, and there's a little mounting point over here. I've just got a cable tie on there. You can mount it down there. And then it pops down here and breaks out over here, and that's going to go to your coil for your left bank. It's then going to pop through these holes over here, and one is going to come down and go to the crank sensor. The other one's going to come down and go to the oil pressure switch. There you go. Then the other one comes down and it goes to the O2 sensor, same as the other side over there. Okay. Now, normally the way the Toyota did it was they brought the wire through the engine block here. Okay, obviously I bring it around to the front to keep the wire as far away from the exhaust as I possibly can. So that's the reason why that comes out here rather than coming out the back as it would normally do over there. Okay, and again, everything is labeled for you guys, so it's really, really straightforward. Okay, right, if you guys are ever wondering why a non-VVTi has two cam sensors, is because basically the trigger wheel down there is 12 teeth with no missing whatsoever. And you could literally run this engine with just one cam sensor and that trigger pattern. The problem is it would take 720 degrees for the ECU to get engine position, because remember that the cam is rotating at half the speed of the crank. So for 360 there, then it has to do another 360 there before the single tooth from the cam actually went past the cam sensor. And what you'll notice, this cam sensor and this cam sensor are 180 degrees out opposite. So the reason they have two is simply that the ECU can sync within 360 degrees of crank rotation. So if you're ever wondering, that's the reason why. So the engine starts up quicker. So if you ever see guys with aftermarket ECUs that still keep the 12-tooth trigger wheel and don't swap it out to the later VVTi one, which I do have one here. So you can see that's a 36 minus 2, so you're missing 2 teeth that would normally be there. So this one can tell you a position within 360 degrees. It just can't tell you whether it's power stroke or exhaust stroke on cylinder 1. That's where the cam comes in. But obviously, when you have no missing teeth, the ECU has no idea what position the cylinder is until a cam sensor pops into play. So oftentimes when the guys are using aftermarket ECUs and they're using that and just one cam sensor, you'll notice the engines take a little bit longer to start. It's not the end of the world, but I just want to explain why there's 2 cam sensors, because you might think it's a bit ridiculous to have 2 cam sensors, but that is the reason why. So the ECU can sync within 360 degrees. Okay. Right, so that's pretty much it for the layout. As you can see, it is really, really straightforward. Obviously, when you come in to install the harness, what you're going to want to do is obviously pull the entire intake off. You'll take this top section off first. There's 4 gaskets underneath there if you want to replace those. The throttle body itself has a paper gasket, so I definitely recommend replacing that. Once you get the top section off, then you can do the bottom section with the 10 bolts that make their way around the outside, and you can pull that off, fit the sub harness underneath, and then put the bottom half on, and then you can fit the injector harness as well as the idle speed control harness, and then you can put the top section back on again. Okay, then the rest of the harness just snakes its way around the engine there, sort of tucked away in there, nicely hidden. And then obviously all of this at the back can obviously then be tucked away however you see fit, and you can just put it all over there. Other things you have to install is going to obviously be your earth for your engine blocks. That's from the negative of your battery to your chassis to your engine block. Depending on the vehicle, some have, monocoques. Some of them will have chassis and body. So you need basically battery, body, chassis, then engine block. Then you're also going to need to do the alternator. So that's this wire over here. So that's the big thick one that's going to go to the alternator there. This is the 12 volt side of it. Now what Toyota do, and what I always recommend, is they actually fit a fuse between the alternator and the battery, close to the battery, obviously, not close to the actual alternator itself. So basically, if your alternator cable was to ever melt on an exhaust or get rubbed through or something like that and it shorted out, it would then pop that fuse. A lot of people and a lot of manufacturers, you should just take the alternator wire from there to the starter and then to the battery. I don't recommend that. It's just that if anything goes wrong, obviously having that fuse there is going to stop your car setting on fire, which is always brilliant. So basically that's it. Okay, so earth for the block. You can also take an earth on the cylinder head, so you see there. Now, this is another one as well. You've got 3 holes here, okay? Always use the top one for the harness because that's a nice flat surface. But you can take another big earthing strap from here to the firewall if you want. I do recommend it actually because these engines do love earths. But it's earth to the block. Then you can do an earth from the cylinder head to the firewall. And then you've got your main power from your alternator to the battery via a fuse. And then obviously you've got your main power for the starter solenoid, okay? And that's obviously underneath there. And you can see that's bolted to the starter motor over there. All right. But that's it. It should be relatively straightforward, nothing too complicated there. So again, nice and super easy. But what we'll do now is I'm going to cut off, get everything ready, and then we're going to come back and do the testing with the ignition on. So see you in a second. I nearly forgot to do the wiring on the plug for you guys. Okay, so right. Really simple. You have one 9-pin plug. If you've seen any other videos, we basically make these plugs exactly the same for pretty much all of our harnesses. So let's go through each wire. So pin number 1 is red and it's a permanent 12 volt supply. Okay. So basically what that means is it needs to go to a permanent 12 volt supply, not an ignition 12 volt supply. Now the reason that is very important, number 1, if you connect that wire to an ignition source, every time you turn the key off, you're going to completely wipe the ECU of long-term fuel trims and most importantly, diagnostic codes. So if you connect that to an ignition source, you're driving along, your check engine light comes on, you turn the key off, well, you've just wiped all the codes. So it's going to make diagnosing incredibly difficult, okay? And if you look down in the link below, I've actually got a really good video on how to do diagnostics on these harnesses, okay? So basically go watch that video and you'll see what I mean. And so if you don't connect that to a permanent 12 volt source, you're going to find diagnosing literally impossible to do because every time you turn the key off, you are going to wipe all the codes off the ECU. So that's why it's super important to connect that to permanent 12 volt supply. Number 2 is black with a yellow, and that is your start signal. So again, really straightforward. It just requires a 12 volts when you move the key to the start position. If you're going to use a push button switch, one side of the switch to 12 volts, other side of the switch to the black with a yellow wire. There it is over there. Right, next up is going to be yellow green, and that's gauge temp. So again, that was when I was talking about this wire over here. So that's temp, and that's coming out over here. So again, if you need to use that, that's where it pops out. Number 4 is gray, and it's a fuel pump. So this is actually going to supply the 12 volts for your fuel pump, okay? On this one, the 95 to 97 LS400 1UZ non-VVTi, the fuel pump is controlled via the ECU, okay? I do have a link in the description below where I've done a video explaining how the fuel systems work. I would highly advise you go and watch that because it always catches people out. Toyota and Lexus do not prime their fuel pumps when you put the ignition on. Okay, so don't expect to hear a fuel pump when you put the ignition on. The only time the fuel pump runs is when it picks up that the key is actually, or the engine is starting, and it does that via a signal from the in this case the fuse box to the ECU to say, hey, the vehicle is cranking, and it'll continue to run as long as the crank sensor is picking up rotation of the engine. The second the engine stops rotating, the fuel pump will turn off. But what you'll also notice is the fuel pump will run for a few seconds after you turn the key off. Now that's because they obviously have a one-way valve system that they're designing to hold fuel pressure, okay, for the next time you go and start the car. Because remember, it doesn't prime when you turn the ignition on. So they need to get the fuel pressure up. When you switch the car off, it'll run for a few seconds, get the fuel pressure all the way up, and it should hold there overnight till the next morning. When you come to crank your vehicle, you should already have the fuel pressure at your rail, okay. Number 5 is yellow with a red, and that's going to be check engine light. Super simple. It just gives off a ground/earth. So you can either take it directly to your cluster, because normally they only require a ground signal to turn the check engine light on. Or if you're going to fit an LED, just one side of the LED ignition 12 volt source, the other side the wire for the check engine light. Number 6 is going to be yellow, and that's going to be a tacho signal. So again, the tacho signal on these engines actually comes from the igniter. So it's a 4-cylinder signal because each igniter only controls 4 cylinders. And obviously that comes directly out here. It's got nothing to do with the ECU at all. So obviously it's just going to come straight from the igniter to here, and you can take that to a cluster. Just bear in mind that it is usually what they call a high level signal because it's coming from an igniter and not from the ECU itself. So do bear that in mind. But if you do need a 6-cylinder or an 8-cylinder, you will need to adapt that signal to work in your particular case. Right, next up, number 7, going to be black with a red, and that's going to be ignition 12 volts. So this is your straightforward ignition 12 volt supply. So when you turn your key to ignition on, or in your case, if you're going to fit like a button or a flick switch for ignition, that's where it's going to connect to. Now, if you are using a key barrel, one thing to bear in mind, on a key barrel, there are 2 places where you get 12 volts. One is called ACC or accessory, and one is called ignition. Now, easy way to tell which one you've got is ACC will lose 12 volts when the key moves to the start position. So if you ever notice when you climb into a car and you go to crank it over, the radio and everything turns off, that's because they're all fed from the accessory feed, not from the ignition feed. So what's going to basically happen is every single time that if you connect that black with the red wire to the accessory feed, every time you go and turn the key to the start position, you're effectively going to shut down the entire thing. The engine will still crank over because it doesn't require the ignition to be on in any way for the actual starter motor to turn over. And what's going to happen is you're not going to notice that your check engine light's turning off when you go to the start position. And then as soon as you let go, well, you get the accessory feedback. Everything turns on. You see your check engine light and you're going to drive you wild. I know I've had a customer do it in the past. And he spent a whole day trying to figure out why. Because obviously from the outside, everything looked 100%. He went to crank it, didn't realize check engine light went off. Let go, check engine light was on. Everything looked sweet, no dramas whatsoever. But yeah, that's what happens. Next up is number 8, that's pink with a blue, and that's going to be your charge lights. That is, again, your charge light, your alternator light, your battery light, whatever you want to call it. Again, it's a ground signal. You can take it directly to your cluster if your cluster has a wire directly for a charge light or alternator light. If you're going to fit your own LEDs, obviously just put a 12 volt ignition source on the other side, and then the ground side of the LED will go to the pink with the blue wire over there. Okay. Now then, just a caveat with this, and I have put it in here, I think, as well, is I have seen on some older vehicles when you actually have the old-fashioned incandescent bulbs in the cluster itself, I have seen where it can backfeed 12 volts through. Because remember, the cluster itself is supplying 12 volts, and obviously they can then backfeed through there. And in one case, I actually saw where the system was so badly backfeeding through because the alternator has an ignition 12-volt source and a permanent 12-volt source. It actually kept the whole system alive, even though the customer had turned the key and pulled it off. If that is the case, there's two easy fixes. One, you can replace the bulb with an LED because the LED is a diode, and obviously then it'll stop the backflow of electricity. If you can't fit an LED inside the cluster itself, then obviously you just fit a diode in the wire here, so it would stop any backfeeding from the cluster into the system itself. Okay, and then lastly is yellow-black, and that's oil pressure. So again, that is connected to our oil pressure switch down at the bottom over there, and it's coming just literally directly through the harness into the fuse box and directly out here. Doesn't go anywhere else, doesn't go into the ECU, nothing like that. So you can run that straight to your dash. It gives a ground signal as all oil pressure sensors do, and you can either run it to your dash if you can wire directly into there, or if you're just going to fit a LED, again, same thing, ignition 12 volts on one side, yellow with a black wire on the other side, and that'll be your oil light. Okay. Right, so those are all the wires explained over there. Like I said, if you watch any of our other videos, it's pretty much exactly the same. Okay, we keep that plug pretty standard. It makes life easier for everybody involved. Right, so let's get back to the testing. Right guys, now we're back for the testing of the harness, and as I said, it's going to be made up of two sections, one with the ignition on and one with the engine running. So you can see I've got the engine ready to actually run. Obviously we've been testing in the background as well, but first thing I'm going to do is I'm going to go through with you all the tests that we are going to do. That's over there, and then we'll jump in and get them done. So on the ignition on side, it's actually quite simple. We're going to do check engine light, charge light, and oil pressure. So check engine light, we've got a check engine light in the fuse box there. That's a little LED there. I've connected up the yellow with the red wire to our cluster here, so we should see the check engine light come up on the dash there. Then in charge light and oil pressure light, that's going to be these two little LEDs over here. So I've got my pink with the blue wire there, and I've got my yellow with the black wire there. So what we want to do is obviously unplug the oil pressure switch and the alternator, and when we should see the LED go off and then back on again, so we know that's working correctly. And that's basically everything with the ignition on, so it's not a lot of tests there. Obviously the brake switch and the gear selector are only for auto vehicles, again, it's not applicable in this case. With the engine running, the starter circuit / neutral start switch, basically all I want to see is that when I touch this black with a yellow tracer wire to 12 volts, obviously with the ignition on, that the engine should crank over and the starter solenoid should engage. That's all I'm testing. If that works, I'm happy with everything. Then next up is going to be fuel pump. Now in this case, as I said earlier, the fuel pump is controlled by the ECU. So basically what I want to see is when I crank the engine over and she fires up into life, that she carries on running. If she carries on running, I know the fuel pump is working 100%. Then injectors and coils, what I'm basically going to do is I'm going to go around the engine one by one, and I'm going to unplug each injector so you can actually hear the engine misfiring, and plug it straight in again so you can see that every single cylinder is firing as it should. Tacho, again, I've taken my yellow wire there, I've connected it directly to this cluster so we'll be able to see an RPM signal. Bear in mind, this is a 6-cylinder cluster and it's giving out a 4-cylinder signal, so it's going to be wrong. I just wanted to make sure that it is actually giving out a signal that can be used. Then lastly, diagnostics. I'm going to go through the diagnostics and show you guys exactly how that all works, and obviously show you how to read codes, but it's going to be a very brief explanation there. But what I will say is there's going to be a link down in the description to an extensive video that I did about how to do diagnostics with our fuse boxes. The same rule applies to all of our fuse boxes, so it doesn't really matter which one you've got, but that video is going to be super helpful, and it's a much more detailed look into doing diagnostics. Okay. Right, so let's jump into the testing with the ignition on. So let's turn the ignition on. So as I said earlier, it's going to be my black with a red tracer wire there. That is my ignition. So as soon as I put that onto 12 volts, and as you can see, we have got the LED inside the fuse box. That's the check engine light. You can see we've got the check engine light on the cluster there. So that is perfect. We know that that's working 100%. Next up, we've got our two LEDs here going to our charge light and our oil light. So first thing I'm going to go do now is I'm going to unplug the alternator. So again, I'm just going to unplug the DTM connector. And you can see there the one LED has gone off. Plug that back in again. And let's pop over to our oil pressure switch, which is just over here. And then hopefully we'll see the other LED has gone out. Yeah, the other LED has gone out, and let's put that back on. And we should see that both LEDs are back on there. Fantastic. Okay, so that's all the testing with the ignition on now. So what I'm going to do is I'm going to get everything ready to do the engine running, get my ear defenders and so on and so forth. So see you in a second. Right, so got my air defenders and everything on, ready to go. What I would say while I've got you here, because I can't do it with one hand, all the injectors are basically just pushed on as far as they can go on. So if you do hear the occasional misfire, that is perfectly fine. It's just because the injectors are not completely clicked on. But unfortunately, I can't hold the camera in my hand and undo the connectors with one hand. Okay, so if you hear the occasional misfire, don't stress out. It's just because the injectors aren't fully on. Right, okay, so without further ado, let's get the engine running and do the first test. So as I said, all I'm testing for here is if I touch the starter wire, which is the black with the yellow tracer with 12 volts, that the engine cranks over and starts. So let's go for it. There you go. It fires up straight away. Right, so the fuel pump, all good. We know she's carrying on running. So let's go over and do our injectors and coils. Okay, so I'm going to start at number 8. Then I'm going to go to number 6. Then I'm going to go to number 4. Then I'm going to go to number 2. Go to number 1. Number 3, number 5, and number 7. Fantastic, so they're all firing as they should. Right, let's look at the tacho so we can see here we've got our tacho signal there. I'm going to give it a quick rev. That's working as it should. And diagnostic, so let me just kill the ignition time itself now. Right, so I'm just going to kill the engine quickly and we're going to discuss the diagnostics. Okay. Right, so diagnostics on the 1UZ non-VVTi, because they're not OBD2 compliant, is obviously done through the check engine light itself. Okay. If you look inside your fuse box there is actually an open fuse there. Okay. In your fuse box lid, you have a fuse puller, and all you basically have to do is, it could be any fuse basically, but I would recommend these ones down here at the bottom because they're not ones that are actually supplying things like injectors and sensors and all that type of jazz. Right, so you take your fuse over there, you're going to bridge it out here. Okay, and you can see there, check engine light goes off, and we've got 1, 2, 1, 2, 3, 4, 5, 6, 7. So that's 27. And we got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 27 and 29. All right. Sorry, I haven't got the fuse all the way in there. Right, but that is how you read the codes. Okay, so number 1, there's no single digit codes. So it's always going to give you a 2-digit code. I think the lowest is like 12 or 13. So you can see there we've got 27 and 29, and then there should be a long pause, and it'll go 2729, long pause 2729. Basically 27 and 29 is the secondary oxygen sensor, so the ones after the cats. Now, luckily on these ones, it doesn't cause a check engine light, because you saw the check engine light go off when we were running it, and you could see it gone off of there when we look at the tacho. But basically, you'll just keep getting those codes 27 and 29 every single time. So yeah, no dramas to worry about that. It's when you get 20, I think it's 28 is one of the other Lambda sensors, and I think 21 is the other Lambda sensor, but that's these main ones in the actual exhaust manifold. So those are super important, okay? Again, I have a link down where I go into much more detail about doing diagnostics, but basically that's how you read it on your harness there. But I would advise you to go and watch that one if you are gonna try and diagnose something. It's gonna give you a lot of useful information before you start diagnosing, okay? Right, so other than that, I'm super happy. She runs great, no problems at all. Every single cylinder is firing, all the signals and everything are working as I expect it to. So that's about it, really. So next thing we've got to do is get it all boxed up, get it off to the customer, and yeah, then you can get it all installed. So if you guys have any questions, please feel free to comment down below. I try and get them as often as I can. You can email us at info@phoenixenginemanagement.com, or you can find us on Facebook. Just search Phoenix Engine Management and you can send us a message there. Okay. But thanks for watching, guys. See you again soon. Bye-bye.